All right. I also want to mention that we will be taking questions at the end of the panel. However, feel free to enter your questions into the chat as you think of them, and we will refer back to them. So to find the chat, you want to navigate to the toolbar at the bottom of your screen and click on chat to open the window. And I also want to just, before we get started, also kind of maybe get a sense of where everyone is joining us from today. So if you could take a moment and just put your location, city and state or country into the chat, that would be great. So once again, navigate to that toolbar and click on chat. We have a Boston local, fantastic. Alberta, Canada, great. Arizona, fantastic. Texas, Maryland, Michigan, awesome. Anyone else from any far away who wants to mention where they're joining us from? Well, fantastic. It's great to see people from across the country and also internationally, our neighbors in Canada. So thank you all for joining us today. North Carolina, great. Thank you for that. It's always great to be able to provide opportunities like this for us to all get together. I think Zoom has really been able to let us all come together to have discussions and meet one another, even with, continuing COVID issues, but it's great to be able to do that. So thank you so much for doing that. We hope that you leave the session with more information about virtual and extended reality, and also maybe a bit about our program as well. But if you do have questions after today, I do have a slide at the end that has our contact information, so please feel free to reach out at a later date. All right, so now to talk about our session. At the School of Library and Information Science at Simmons, or we often just say SLIS as shorthand, as I'm sure many of you are used to hearing things like this, we have a research lab called the UX and Emerging Technologies Lab. Some of the research that you'll hear about today is by faculty who are part of this lab. And joining us today, I'll give a little bios of everyone. We have Catherine Dumas, who is an assistant professor, thank you, Catherine, who specializes in knowledge, organization, and management and information and organizational environments. Her research explores the usability of XR technology applications, and it's motivated by data generated by platforms potentially used for online collective action or digital activism. Using data mining techniques and online collective action theories, her work is exploring the impact of new information communication technologies, ICTs, on the phenomenon of online collective action. Catherine is also the co-director of the SLIS UX and Emerging Technologies Lab. Next, I'll introduce Sarah Pratt-Martin. I'll give a little wave, thank you. Who is also an assistant professor of practice, who primarily teaches in archival studies. In addition to obtaining her MS-LAS from Simmons, Sarah also has a master's certificate in UX research and design from Michigan. Her teaching interests include archival studies, engaged learning, reference, outreach, and advocacy, and her user instruction and experience. And next we have Jeff Pomerantz. A little wave, thank you, as an associate professor of practice and the coordinator of the SLIS online program. He was the PI on the HP EduCause Building the Campus of the Future project, the broadest study to date of VR and AR technology in higher education. He is an associate editor of the Open Access Directory and a co-founder and thus far successful startup building education VR experiences for the cultural heritage sector. Sorry about that. And then next we have Rachel Williams. Thank you. Is an assistant professor in SLIS who teaches courses in a variety of topics, including public librarianship and technology. Her research examines how public librarians support people and communities in crisis, and most recently, how VR and AR may be a useful tool for training and support of the provision of those information services. And then lastly, I'll introduce myself. I'm the Director of Graduate Admission for the School of Library and Information Science. I'll be helping with questions and moderating a little bit today. But with that said, I really want to pass the baton over to my colleague, Catherine Dumas.
I guess I should unmute myself. So hi, thank you, Kate, for the introduction. I am Catherine Dumas, and I will be talking about one of the projects that I'm currently working on. It's VR Dialogue, and I'm exploring user behavior and interactions on next generation social VR platforms to improve communications. So VR Dialogue is a project that's part of the Next Generation Internet Explorers program that my colleague Lucas Porwall from the National University of Ireland in Galway and I have been working on for over a year. And it's funded by the European Union's Horizon 2020 Research and Innovation Program. Next slide. Sorry, Kate. So just to get some context and terminology out before I go on. So VR stands for virtual reality. And that's when you're fully immersed in wearing a head-mounted display, like the person in the picture. AR is augmented reality, and it's an enhanced version of the real physical world. And that's achieved by the use of digital visual elements, sound, or other sensory stimuli using a technology. So here in this picture, you see someone using a tablet that is using software that is acting like a lens or like an overlay over the physical object. And that physical object is a model of the body. Another example of augmented reality that you may be familiar with is Pokemon Go. And XR stands for extended reality, and it's just basically an umbrella term for all that is VR and AR. Next slide. These are common domains using XR technologies. So governments use them in defense. There's a lot of research using XR in the medical field. Engineering is a huge area. XR is used in different types of training, and also they're used in the automotive industry. Fun fact, Volvo has one of the most expensive VR headsets in the world, and they use it to better design their cars. So in my research, I'm interested in social VR and serious communication in the areas of e-government, business, and education. So what, oh, sorry, thank you, Kate. So what is social VR? Basically, it's just people getting together in a simulated world using a VR system and a social VR application. Next slide. So here are some examples. So Facebook has Horizon, which is very new. It's still in beta. And then Microsoft has AltSpace VR. And then we have Mozilla Hubs, which is the platform that we use in our research. Next one, thank you. So basically Hubs is a VR chat room, and it's designed for every headset and browser, and it is an open source project. So you can go in one of their virtual rooms, or you can actually build one from the ground up. So we have built the instances that we're using in our research, and we've programmed them to collect behavioral data from all of the users that are in the room during a session. And the data is collected on our server, so we're able to analyze it. And one of the main reasons we're using Mozilla Hubs is because it is open source, and we are able to write some code that will allow us to collect the data. So right now we get the position of the body, the position of the head, so that would be the gazing, and if the person is talking or not, and how loud they're talking. And we also get the hand gesture data. Next slide. So here are two venues that we created. The one on the left is set up like a room you would be in a presentation at a conference. And so we had two of us on the stage presenting to an audience, and we ran through 6 different scenarios. For the first session, we were presenting and we told the audience to focus on us without any interaction. For the next session, we told the audience to focus on us, the presenters, and to interact with us. And for the next one, the audience was told not to follow the presentation and to act distracted. And the next one, the audience does not follow the presentation and then roams around the room talking to each other. And in the next one, all the participants gathered together and talked to each other. And the last session we called collaboration, and that's where everyone talked, interacted, and then collaborated by drawing complex 3D shapes together. So we did the same session in a different room, which is the right image. This room is larger, more open, and the presentation screen is huge. We wanted to see if the setup of the room made a difference in the user behavior, and we found that it didn't. So for these 2 sessions, we collected all of the user data, behavior data that I mentioned earlier. Next slide. So we built a data collection infrastructure as a research platform for exploring different immersive virtual reality online meeting scenarios. And that will allow us to analyze user behavior and collaboration patterns. So along with Mozilla Hubs, we're using AWS server to store the data that we collect. And then we're using artificial intelligence to train the models for data analysis. Next slide. So I'm not going to get too technical, but basically this is the setup. So the Mozilla Hubs VR data logger will send data to our VR dialogue API, and that was implemented using Node.js. And then we also used libraries that would handle the API endpoints, and then we use Sequelize to for the object relational mapping for our MySQL database. And then once the data is stored in the database, we used a module written in Python, and that was used for the AI-driven data analysis. So what the AI processing allowed us to do is apply relevant feature engineering, and that helps us to capture some important aspects of communication and collaboration in VR. So the features in this case are body position, head position, gazing, talking, hand movements, and drawing. So I'm going to stop there and segue the next presentation by Rachel Williams, which is a project that I'm also working with her on. And we will be using the hubs and this data collection infrastructure that I just presented in her project, but in different use cases. Thank you.
Thanks, Catherine. So hi, everybody. My name is Rachel Williams, and I'm going to speak briefly about the project I'm working with Dr. Duma on related to virtual reality training in libraries. So this will be like the slightly less techie version of the presentation. Next slide, please. All right, so first off, as you can imagine, virtual reality is a growing trend everywhere, and particularly in libraries, and recently in public libraries as well. So more broadly, virtual reality has had an increased use in higher education of late, including, for example, in instruction for education and social work students. So specifically in terms of library services, virtual reality has become more popular when it comes to thinking about how we design programming and services that implement VR. For example, the image that you're looking at on the slide here is of 2 people at a public library in North Carolina. There, a community partnership enabled the library to use VR to develop programming that was designed to help community members, particularly seniors, overcome social isolation and sort of expand their horizons throughout the pandemic when many felt and still may feel disconnected from their communities. So it's clear that VR has a role to play in library services, and the American Library Association, which is one of the largest professional associations for librarians, points out that libraries are a great space for people to engage with VR technology for the first time, or any technology really. Libraries are also great for supporting personal connection, as I mentioned with the example here in the slide, as well as everything from book clubs to virtual reality story times. Next slide, please. That said, libraries are more than just places where patrons use new tech or connect with each other. Libraries, particularly public libraries and their staff, also support their communities as a whole. Particularly when those communities face crises such as natural disasters like a hurricane, or with the COVID-19 pandemic, where many public libraries have served as testing or vaccination sites. However, beyond supporting communities themselves, libraries and their staff also support individuals who are facing crises. And this can include things such as difficult personal situations like facing a mental health crisis or dealing with housing insecurity or a substance use disorder. So what's clear here is that because libraries and their staff are doing all this support work for their communities and for patrons at an individual level, they do need additional support and training in crisis management. So my interests in VR then are focused on how not on library services, but on how we can develop training and professional development for library workers. Next slide, please. So my current project with Dr. Duma is implementing VR training for librarians, supporting patrons in crisis. In supporting people in crisis, library staff face particular difficulties when it comes to balancing the needs of library patrons with taking care of themselves. And so a crucial component in finding that balance involves bolstering training for librarians so that they feel empowered to support patrons in crisis both effectively and confidently. Social work approaches, including thinking about how we care for others, as well as how we focus on our own well-being, can help inform librarian training and overall professional practice. Some of my prior work with a social work faculty member identified some training opportunities for library staff, particularly around self-care practices, developing healthy professional boundaries, and interacting with patrons who are experiencing mental health crises. From there, we developed in-person workshops that included a series of role play and active listening exercises that were really helpful for staff. However, what came out of those workshops is that staff wanted more. They wanted more opportunities to practice and engage with the concepts related to crisis management and self-care, and they wanted more chances to work through the scenarios that we gave them. So one way that this is possible is through the use of virtual reality, right? We can create these training scenarios. Social work as a field already implements some virtual reality training, again, like in higher education. So it seems like a natural extension of that approach and partly how I got interested in pursuing the project. Dr. Duma and I are partnering to develop some VR scenarios then that kind of mirror this in-person training that I've already done in another project. So our current project focuses on a couple of key questions. First of all, how do library staff view the usability of completing virtual reality workshops? And are virtual reality workshops a good alternative to in-person workshops? How do those compare? So in terms of students, we involve students in a couple different ways, but just one exciting opportunity that I wanted to point out includes an opportunity to actually try out some of these training scenarios, or at least that's the goal, in a class that I'm going to be teaching called Crisis Management and Rapid Response in Libraries. So in the class, students will have an opportunity to work through some of these training exercises, both for knowledge building and also to just give feedback on how they work before we try them out in other contexts. Hopefully some of the positive outcomes that will come out of this work are the ability to reach a wider audience. There's no harm to clients in virtual reality training. You can do the training as many times as you want to. You can start over. You can make lots of mistakes. It's a very low stakes, positive experience, right? And also just the immersiveness of VR training and the presence and attention that you give in that environment may help keep people more engaged in this training. So ultimately, we're also hoping that the studies will show some ways in which VR training is useful for library and information science education, as well as continuing education for library staff. We're also hoping the study will show increased confidence in crisis management among both students and library professionals. So thank you so much. I'll wrap it up here and hand it over to Sarah Pratt-Martin.
Thanks, Rachel. I want to audit that class, so I can't wait. So hi, everyone. My name is Sarah Pratt-Martin, and I am an assistant professor of practice at SLIS, as Kate said. I'm going to be talking about a project that is also with Dr. Duma. She just can't keep her hands out of all of these things. I think it speaks more to her expertise in the field than anything. A little bit about that. I am certainly not an expert in data visualization, InfoVis, XR, but I do approach this project from a usability research and design standpoint. So I'll be speaking a little bit more to that. So the information visualization field, or InfoVis, is exploring new environments and increasing accessibility for new users and across different platforms. Exposing new users to InfoVis has allowed researchers to understand alternative ways to engage with visualizations, including more casual or entertainment-based purposes. In our research, we look specifically at developing a gesture vocabulary to interact with complex and novel data visualizations on a screen. So what does that mean? We mean without instruments like a mouse or a pen, without being able to touch the screen, or without giving speech instructions to a system. Thus far, InfoViz has explored these modalities, these instruments, touch and speech, but mid-air gestures have been overlooked mostly in the research. And why is that? Well, because the equipment required, like you just saw, those headsets, not everyone has them, or issues of recognition. Users don't all perform gestures in the same way. Now, however, with the support of current technologies, mid-air hand gestures could be used in conditions where instruments, touch, or speech prompts are inadequate, especially when we think about, for example, loud public spaces like a museum or library lobby. With consideration to COVID-19, touchless or instrument-free interaction is becoming increasingly important for public displays as well. And out of this, our research project was born. Next slide. To give you a sense of how these projects work, I'm going to give you a quick overview of our research and the steps we took from start to finish. And I will also share, it's not finished, so start to where we are now. So first I'll talk about the elicitation study. So first we conducted an elicitation study to elicit or draw out a group of gestures that felt natural to our participants when it came to performing certain tasks, like selecting a data point or filtering data, tasks that you would normally complete using a mouse or a drop-down menu. In order to do this, we first had to recruit participants and schedule their session, which takes longer than you think. We conducted all of these sessions via Zoom because of COVID and keeping us away from being in person. The cool thing about the elicitation study is that Catherine and I's other research partner created simulated visualizations that were animated to show the desired effect we want each gesture to have. We recorded all the sessions and then our research team analyzed them after the fact. We calculated agreement rates, which is essentially just seeking any sort of consensus for a desired effect. Did users use one hand or two? Did they use one finger or an open hand? Did they use a closed fist? Once calculated, where there was and was not agreement, we used this information to develop a gesture vocabulary or a set of gestures to be implemented in our user study. Next slide. The user study started out just like the elicitation study with recruitment and scheduling. While we were conducting the sessions over Zoom, we also needed to send participants equipment, a Leap motion controller device, which you see depicted in the image all the way to the left of the slide on your screen in front of the laptop. It plugs into your machine and then it's a little device about this big that has a sensor that senses your motion above it. And we had our participants install the device on their own personal machine. A member of our research team developed this awesome tutorial, which you can see depicted on that left image, that helped participants get comfortable with the technology and the gesture vocabulary before we started on the most important part of the user study, the task set. And you can see in the very leftmost image, this is where users get a sense of where the controller actually sees their hands. The task set included 14 different tasks, some of which you can see on the image on the right side of the slide, which range from selecting a single data point to filtering by time. I'm doing the motions, I can't help myself. Filtering by time, zooming in and out of the visualization, or moving data that's out of view on the screen into view. Our moderators, which was just Catherine and I, split up the sessions, but the two of us worked from a script so that users were getting the same experience no matter who they worked with. We recorded each session and asked the participants to think aloud and show with their hands, as I've been doing this whole time, in front of their computer camera so that we could see the gestures clearly during our post-session analysis. When we watched the sessions back, we looked for recall. Could they remember the gestures from the vocabulary that we taught them in the tutorial? And execution. Did they actually perform the gestures correctly and for the correct tasks that we intended them to be used for? We also had participants complete a post-study survey that asked after their experience, what did they like, what did they dislike about using the gestures to control the visualizations? Did it feel intuitive or natural? And how did they see this being used IRL in real life? Next slide, please. So ultimately found that gesture vocabularies need to account for several things. Participants brought with them a lot of bias. Legacy bias from working with WIMP interfaces, which is windows, icons, menus, and pointers, as I'm sure all of you are familiar with. Physical bias, like what we're used to experiencing in the physical world, like turning a doorknob. And cultural bias, for example, in the US, putting one hand up like this generally means to stop. We would work with these biases, rather than against them when designing gesture vocabularies. The other important takeaway was disambiguation. So making sure that gestures were distinct enough from one another so that users could more easily distinguish between them and thus recall them. It's also important to consider ergonomics and possible fatigue for a given gesture, especially if it needs to be repeated again and again. It's really important in the same vein to account for accessibility concerns, especially for displays in public spaces, so that differently abled users could communicate with and interact with the system. And lastly, users want to feel like they are connected to the technology. And since they're not wearing a wearable, how to make this system still a connection or an extension of themselves. And they want to feel confident that they're using the system correctly. When we execute something on our PCs and we get an error message or we get some sort of noise that says you did something wrong. So we need to also think about the system providing appropriate feedback. So that's just an update on where this project stands. We're still in the midst of writing and rewriting all of our research, but we look forward to continuing this work and continuing to explore it, and hopefully in person sometime soon. So thanks so much, and I'll pass things over to Jeff.
Thank you very much. So I am going to go in a somewhat different direction with the stuff I'm going to talk about. Rather than talking about a project that I myself am working on, I'm going to talk about things that you, our audience members, might work on. And my colleague, Dr. Williams, said that that project involves students, and of course, a lot of the research that we do in SLIS involves students contributing to the research project. That's an important part of the work that we do. However, I want to talk about an area where XR work crosses over with somewhat more traditional library and information science work, where there's a wide open area that you too could contribute to. Next slide, please. So never mind that nonsense on the right-hand side for a moment. This is a 3D scan of a artifact that's in the Harvard Museum of the Ancient Near East. So this isn't actually a photo. This is a 3D scan. So if you go to, there is a collection of materials online called Sketchfab, which you may be familiar with, which has some 3D objects that have been created from scratch using like CAD/CAM software, 3D modeling software, and some things that have been 3D scanned. So if you go to Sketchfab and you look for this artifact, you can rotate it, you can lift the lid up and peer inside of it. Anyway, the idea is that this is a 3D representation of an actual physical object in the Harvard Museum's collections. Now, to look at the text on the right-hand side there, this is metadata. And for those of you who are current students, you know what that is already. And for those of you who aren't, basically metadata is just data about an object, about some resource. The resource here is the 3D scan of this coffin. If you look at this metadata, and I'm not expecting you to be able to parse this, but what this says is this is data about the 3D model. And if you look closely, it shows things like how large the file size is, what the geometry of the model is, the fact that it's animated, stuff like that, right? It is representing the 3D model itself, not the original coffin that's sitting in a museum somewhere here in Boston, right? Next slide, please. On the other hand, you get a 3D model and its metadata record like this one from the Smithsonian Institution. And I would just like to, take a moment to point out how large the 3D scanning rig must be to scan an actual physical skeleton of a mammoth, right? So this is a 3D model that the Smithsonian has up on its website of a mammoth skeleton. And if you look at the metadata record on the right-hand side, and again, I'm not expecting you to be able to parse this closely, but what it says is it's providing data about the actual mammoth skeleton that's in the Smithsonian's collection, right? The where it was found, taxonomic information about that particular species of mammoth, the person who found it, et cetera, right? So on the one hand, you've got a record that describes the digital object, and on the other hand, you have a record that describes the physical object, right? And these are both 3D scans of actual physical objects. So we have this complete disagreement about what a metadata record about a 3D object should even represent. So here's your problem. So next slide, please. There is a project called the IIIF, the International Image Interoperability Framework. And that is a project to develop a framework, forgive me for stating the obvious, basically a way of representing in metadata what needs to be said about images so that image collections online, like from museums and other types of cultural heritage institutions, can share data about those images and the images themselves, right? So that those metadata records and the images themselves are interoperable. They can move between institutions and online collections, right? Now, again, the metadata record on the right-hand side doesn't matter, but again, this particular record talks about the digital resource, not the physical painting that this is a representation of. So the IIIF metadata record is about the digital representation of a physical object. Next slide, please. The IIIF has a 3D community of interest, right? A group that's trying to develop metadata about 3D objects. This particular object is Jane Austen's writing desk, actually, out of the British Library's collection. And this is I'm sorry, it's so small you can't read it, but this particular metadata record has some traditional IIIF metadata about the digital object, and then some bits about the 3D features of the asset, how large it is, what the rotation of it is, and things like that. So the 3D community group is trying to identify right now, I mean, actively, this is an active ongoing group, trying to identify the state of the art, what is being done to represent in metadata 3D objects across museums and cultural heritage institutions generally, and what the needs are for those institutions going forward, right? Which is great and a useful project, but next slide, please. The problem is that there are some pretty basic issues that need solving before anything meaningful can be done. Like, for example, which end is up, right? Different applications, excuse me, different pieces of 3D software represent 3D objects differently. They put different axes up, rotate things right or left, clockwise or counterclockwise, right hand or left hand. And so there are some very basic bits of interaction functionality that need to be resolved before it's even possible to develop meaningful metadata to describe these objects. And so I'm going to end where I began, which is that metadata for VR, AR, XR objects in general is a wide open area. This is an area that is an active area of research and development, and you too can make some meaningful contributions to an area where we generally think of this as being fairly established in the library and information science professions. When you come to grad school, often you think that you are stepping into a fairly well-established body of knowledge. you're treading where others have tread before you. And up to a point, that's true. But one of the cool things about information science is that some of us more than others, most of us here certainly are right up on that edge, right? Working at kind of the cutting edge of the profession. And you too can make a fairly meaningful contribution to the future of the way we represent this type of object for cultural heritage institutions and other types of institutions across the board. So rah-rah information science. Thank you. All right. Now I'm going to hand it back off to Kate. Thanks.
Thank you, Jeff, and thank you, everyone. I haven't seen any questions come in, but I would love it if people did submit questions. I don't know if we're taking them. I'm going to defer to Catherine. Are we taking them here? Are we going? We did have.
How many people do we have?
We have about 15, I would say, or 16, 21, including us.
Okay, yeah, the room can handle 25, so I think we can go to the room if everybody wants to check out the space.
I think it would be pretty cool. I think it would
Okay.
be. We have a couple more minutes. The session goes till 4:45, but I'm sure if people want to hang out a little longer, we could also do that as well. So
Okay, so I'm going to grab the link and put it into the chat.
fantastic. So we are now going into, believe it's Mozilla Hub, correct? Is that where we're going?
Yeah.
Okay. So one of the kind of realities that Catherine had mentioned earlier. So you have like a little avatar that you can be, and you can kind of walk around a room. So we hope that you all join us in there. You can also keep your Zoom open as well. So we did that before. Just make sure that you are muted in your Zoom if you go into the hubs, because you will have some feedback because you are able to speak in the room when we go into it.
Okay, sorry. I'm just
No,
opening up the
fine.
presentation to get to there. Yeah, so this link I give you is just going to be, you just click on it in your
Great.
browser and
So think of
okay,
questions.
I've got it.
Got it?
Yeah.
Great.
Oh. Thank you, Rachel. I think you can get the H too. Yeah, cool. I'm sorry, I had to open it up and my computer's like
You're
dragging.
fine. Oh, great.
Okay.
Wonderful. All right. So everyone make sure you're muted when you go into it, and we'll see you in there. I'm also sharing my experience, I think, as we go in.
Yeah, that's good. That's good.
You were muted, Catherine.
I know. I just saw that. Thanks. You're muted.
Of course.
Yeah.
It's as if it's my first day. I want to thank everyone for joining us, and I want to thank all of you panelists. This has been fantastic, and I hope that people get a good sense of the research that you're doing and just the possibilities out there as well. If there are any more questions, we're happy to take them, but we also know that people are going to probably go off to other sessions soon. I did put our admission office email there. It doesn't have to be just admissions questions. If you have questions that we can pass along to anybody who spoke today, we're happy to do that. So please feel free to reach out, and I can just put the email here so everybody has it. And enjoy the rest of INFOcon. And thank you again for joining us. Thanks, everyone.
Yeah, thank you, everyone. If you have any other questions, definitely get in touch with us. Thanks.
Thank you.
Well, everyone have a great evening, afternoon, morning, perhaps, wherever you are. And we'll hopefully be in touch with some of you soon. Bye, everyone.
Bye.